Well, hey everyone. We really appreciate your presence here because it's like 5:30 in the afternoon after a full day of conference. So thanks for coming to hang out. We want to make this as useful as possible to you guys. So we want to talk about challenges of the enterprise edge computing world for sure. That's what we're here to talk about. But we aren't going to hit you with a bunch of slides unless you ask us to. We really wanted to be able to dive in and answer questions. We are really, really good at going off on tangents for super long time periods.
Well, maybe
we'll try and keep bringing it back the best we can, but we really just want to give you guys a chance to ask questions in chat, or if you're doing something similar that you wanted to mention. This is for people who are solving similar problems. So we'll go ahead and open it up. And also, warning, if you don't pay attention, you could be hit in the face with a shirt at any moment because we're going to throw shirts at you if you ask a question, assuming you want one. If you ask a question, tell me your size when you do, and I'll grab it. We have medium, large, and extra large here with us. So free shirts for questions. Who wants a shirt? Who wants to go first? Who's got a question? Got one right here. He's got you.
Hello in the back.
Ladies and gentlemen, boys and girls, where are you guys from? So you can set the context.
Wow,
I just
who's
walked,
the radio
I just walked
announcer?
in off the street, I'm sorry.
Oh, okay.
Yeah.
Well, welcome from walking in off the street. Yeah, so we should do that. So I'm Brian Chambers.
Hi, I'm Michael Henry.
Yeah.
He works for a chicken sandwich company. I work for the government.
Yeah. Yeah, that's pretty good. And yeah, I'm from Atlanta. And where are you from?
Sort of all over, as the military does, but I am from the Washington, D.C. area.
You want to take your shirts?
I'm I don't know,
It's like medium.
born and raised bureaucrat, apparently. Turned technologist. Yeah. Mike?
I will talk loud. So, in the earlier session, you were kind of going back and forth a little bit about hardware and hardware consistency. And on the one side, it was, well, that's just good architecture to have consistency. And on the other side,
Yeah.
it was like, yeah, right, that's a luxury we don't have.
Yep.
For sure.
So this is not a question with an easy answer, but I'm curious kind of for your thoughts, is in the environment where consistency in the hardware is a luxury you do not have, and you're in disconnected environments, and in some cases you're on disconnected environments on non-homogeneous constrained hardware, what are your thoughts about dealing with that? Like, a lot of times the initial reaction is like, encapsulation, we'll build a layer and we'll run everything on top of the layer, and that's how we're going to solve this problem.
Negative, Ghost Rider.
In that way,
This one's all you.
resources and
Yeah.
stuff. What are your thoughts about dealing with that in those worlds? Like, what do you do instead? What works? Does anything work?
Okay, so some things work. Hold on, does this work? Does this work? Does this work? I'm digging in my bag. Does that one work? So you gotta have multiple options like, ooh, bag of wires, nope, bag of connectors. So I think I'm trying to make my point here. Maybe not so succinctly, who knows. I did have another node here so I can just tell you or show you, because I like to wave these things at people. Specifically this whole idea of, oh, we're gonna greenfield? No, sir, you're not. You're not greenfielding squat, but you can do this, right? You can take one piece of hardware, and this is now your mother, this is your sister, this is the rest of your family members, and you better memorize every single piece of how this works. Oh, I took the NVMe out of this one, that's why it's doing that. And this is just a prop at this point. But really, like, you know, when you start doing edge work, I don't care if it breaks the warranty, buy another one, tear it down. Tear it all the way down to like every single, like anything that'll come apart, tear it apart, inventory the whole thing. You know, maybe you can get one of those roll-out blue silicone mats, but really understand exactly what you can do with this, right? What they designed it to do, and then also like, how can I push it, to coin a phrase, beyond the edge? How do I push it over the edge such that like you can oversubscribe this thing? These originally came only with 1 terabyte of storage. So I went with 4 terabyte NVMe's. Did it overheat the thing? Yeah, it sure did. So I scaled it back to 2. And then, like, you know, what did they give you inside of here that they didn't really want you to use? Is there additional capabilities to this? Does it have like an M.2 modem capability, which this one does actually? So I can now put a modem in here and play that game, drill a hole, here I go, kind of thing, right? I can't do the modem piece with these kinds of things because they go in very secure rooms. The piece of my talk that I didn't focus on was, yes, I do edge computing, and I also do, you can think of it as almost like, so I'm responsible for all the supercomputing in the Air Force that happens in very, very, very dark, you cannot go there rooms, and that is the edge. It's very much the edge. The air gap environment that some of the experts in the middle of the room here, I got a shout out to my Defense Unicorns friends, they've been working on air gapping edge for a while. Part of the problem is now I'm air gapping an entire data center, and I need to bring in tens of terabytes of data in order to keep that fresh, because we are providing an analytic bulwark against our other nation competitors. Is that a comfortable way to calling it that? So essentially, there is this like real problem with like you have to understand what you're inheriting when you walk in the room, and you also have to understand that you can't turn it off. You really cannot. He's got the luxury of that pickle brine chicken sandwich money, so they can just like standardize their whole fleet and do those kinds of things.
Yeah, that was a super like snarky dig comment, not anything that I expect most people to be able to actually do.
My kids eat it at least twice a week, so not only am I a fan, I'm also somewhat of a member. So we have old legacy architectures that are running that we just cannot turn off, right? Some of that stuff is on serial bus, or we have no spares. VAX machines are not antiquities to us in some regards, right? So what I'm looking for in an edge node is I'm looking for more than one port. So this now works, but the Raspberry Pi was trash for me before. Did I have to cut the metal face on this in order to get the add-on card? Yeah, so that's not scalable. This, 4 ports, it's actually overkill. You can get away with 2 ports, any 2-port node, but you really have to understand it. And then what's the architecture? Are you on x86? This is an Atom chip. This is the 3950 chip. Are you on ARM? Are you RISC-V? Are you doing something, new and different? New and different's usually bad. It could be really cool, but it's usually bad to start. So dealing with fleet management of let's call it your prototyping lab. You like dog food every single thing you do, and this one piece is like your North Star, your Helm's Deep. This is everything to you. And if you understand how to compose this, then that is your one bastion to execute your strangler pattern. And that's definitely what I think of edge. I think of it as like a strangler fig problem, because there are so many like kludgy Soho devices that have been dropped off at random bases for random purposes, various Cisco ASAs that are end of support, end of life, end of support. I need to be able to like grab those and affect this thing. So there's another thing that I carry with me almost regularly, and of course I'm going to fail myself now, is a console cable. I plug a console cable into this thing, and I'm like, oh, I can set the COM port speed, so now I can get after this thing, right? So, and I just use those leave behind console cables. So if I need to be able to like manage a switch, console cable goes into this thing, and sure, maybe it's a crappy Cisco switch that's end of life, but it totally will take a console, and so now I can feed it a switch config from 10,000 miles away. Does that answer the question?
Yes, I think so. Restating that, thinking about it a little bit, like in the world you're in, where it sounds like integrating with and automating equipment that's already there that you can't control with interfaces that you have to deal with what's there.
Yep.
Have a device that you can use that essentially add another interface into the system that lets you get to an interface that you can't control that is reliable, right? Like a
Edge controller.
A translator.
Edge controller is what we call this, yes.
The two kind of, that makes sense to me. I think the other two things that pop into my head are if you, and maybe this is not a world you're living in, if you are having to run software on those things that you can't control and sort of dealing with that world, and or now you've got a config sprawl problem potentially, right, where every one of these has a different config depending on the environment it goes into. How do you control that, and are you trying to reduce the amount of that you have? Like, how much
Yeah.
effort are you putting into, or do you just assume whenever you deploy one of those, it's a one-off, and
No,
I'm gonna
the idea is to
control it,
turn
but-
off the old stuff, but you can't turn off the old stuff without convincing the old guard, because this is very much a people problem, organizational problem. You have to convince the old guard that it's going to work, that it's been working for months. Can we please turn off the old thing? So you have to allow them to do that, and the only way you do that is you write glue, and you do the integration against the old stuff, or you run adjacent and then have that be inside of some VLAN or something along those lines that is on your operations network, and then you can turn off the old stuff, or you can consume the old stuff, just make that declarative infrastructure as code, build yourself an agent, like what we call them an operator. We use Ansible operator pretty heavily. Use an Ansible operator, apply that Ansible operator to that specific problem. Oh, and the other thing is you can only take so much with you. So assume that this is going to be semi-connected over certain periods of time. Like the bootstrap isn't the entire thing. You have to be able to do this like refresh update. How do you do the refresh update cycle? What's the day 2 ops on this box? This is not like a fire and forget, and it's gonna have like a nuclear half-life of, some fissile material. That's not.
Maybe can you just flesh out a little bit more when you're talking about an edge controller, like just enumerate really quickly like some of the key functions that it actually plays in your mind.
Oh, for sure. In my mind, edge controller is actually a container. This happens to just be a vessel, right? So this is just a vessel with a bunch of ports. So I'm a huge Podman fan because I'm not a huge Docker fan. If anybody is working heavily with Docker, I'm sorry. It's just I don't want a natively rooted container. So Podman is far more secure, go with least privilege. So we actually call it Babu Frick. I don't know if I'm allowed to say that now because of like the mouse might. Yeah, so the idea of doing the things that it was never designed to do, and then build that as a container, and the rest of this, we understand the hardware platform really well, so we know how the container will interact with this device. So this is the entire lab in itself. The rest of everything, you hold at arm's length with extreme concern and caution. Health checks are a big deal. Test, deploy, test, deploy, test, deploy, health check, all the way down the road. Does that answer the question? Oh, and we also have a Docker. We are running Docker and Podman and the same thing with customized namespaces. Unless you have a Linux dude, maybe a team of Linux dudes that actually like really know what they're doing, writing your own CNAME group on Linux and then bootstrapping that is, yeah, I know, maybe you're the guy that I need to work with. And doing that in a very secure way such that it doesn't like step on systemd in a weird way, because that's the problem with running Docker and Podman in the same context. Getting that right, and then also applying this horrific thing known as the dissystig. Yeah, and so we do have one item on our dissystig poem, which is essentially allowing these namespaces because the dissystig disallows that. But I don't know, 10,000 hour principle on one box. And I made this comment a long time ago to somebody about Raspberry Pis. I said, your entire lifetime of computer science lives inside of a tiny $85 computer now. You can die with this thing and not need another piece of hardware. Like it really, all the complexity you ever want lives inside of a tiny little system on a module type action.
Do you want a shirt?
You need a shirt.
Yeah, what size?
XL.
XL. All right, I'll let you check it. Throw it back at us if it was wrong.
It's all good. Thank you.
Yep. Okay, next question. I think we had one right here in the front that was second earlier. So sorry. Oh, actually, somebody already has the mic. You go ahead. We'll come to you next.
Sorry about that.
All good.
Yeah, a question for you. You mentioned how you have you use GitOps to deploy to your NUCs. What happens when you have when you bring in other hardware? Do you layer, or how do you handle if you were to introduce different hardware into your system, where GitOps will start to sort of fall apart in that case?
So for us, we don't actually currently have that reality, but I guess it wouldn't matter too much because sort of the substrate that we're dealing with in our world is Kubernetes for GitOps. So as long as there is K3's Kubernetes then that works for us. So we could change out multiple things below that, and that would be fine, or use something else that would support a GitOps model, I suppose. But yeah, we don't really have to worry too much about that because it's effectively a Kubernetes-centric GitOps implementation. So what we did is basically the same thing you would do with Argo CD or any of the other open source projects that are out there today. We just did it kind of early. So does that answer the question okay?
Yep. I'm
Awesome.
good. Thanks.
Shirt? Size?
I'd like to think I'm a large, but probably next week.
All right. Like I said, you can trade if there's still left.
You
so.
identify as a large?
All right.
Yeah.
Over here.
Yeah. So, hi, I'm Moshe from a project called Edge Lake, which is an LF Edge project. And I'm curious about your data strategy. Can you talk about what do you do at the edge in terms of data? What do you move to the cloud? What are the considerations? What are the complexities that you see?
Yeah. There's a whole bunch. You want to start?
Go ahead. You got
Okay.
it. I talked a lot
yeah,
already.
great question. So the very first thing that we do in our world, because we have the luxury of doing so, is we try not to make many persistence guarantees at the edge. So the nature of a lot of the data that we have flowing around in our store is that it's useful for a really short time window. So maybe like it's informing some sort of decision that a person is going to make in the next 60 seconds or something like that. So if it's lost, that data is lost, really not a big deal. So we do persist things, and we do offer like a database service, for example, as well for convenience. But we didn't want to get into a ton of really sophisticated storage stuff. I think we would do that differently in a future iteration, potentially, as that's gotten, I don't know if I can say easier, that's gotten maybe more accessible. I don't know, I'll let you talk about that.
Yeah, sure.
But yeah, so we tend to send things out to the cloud that are business-centric first. So if it's something that we care about from a business perspective, that's going to go out. I kind of talked about telemetry this morning and how we think about that. So that's really minimal and only when needed. And we try and have all of our applications that live in the restaurant kind of funnel through the edge so that that applies, and we don't have lots of like random thing talking directly to the cloud over various networks in the store as well. So does that help at all, or you want to go deeper on anything? You can just yell at me.
So we, for example, we have a customer similar, 20,000 tweeters. You're looking at refrigerators. They move the data right now to the cloud, huge cost. But they do it because if the refrigerator breaks, then you could lose a lot of. It's a real problem.
Sure.
So they're trying to predict it. And to predict it with AI, you need the history. But the cost at the cloud is huge when you have a lot of data coming in, even from a simple thing like refrigerator or air conditioning. So I'm wondering, I mean, what I see now, when I don't get it, in most cases, I don't see that they're able to push processing to the edge and keep the data there. And so they're kind of torn between we want to have the data, we want to be efficient, but on the other hand, if we start to ship it to the cloud, it is really expensive and complicated.
I think it's a question of where you're going to make your trade-offs, right? Like, do you want to invest more in your edge infrastructure so you can store more, have better resilience, have more compute capacity, and then therefore like solve that problem as a local problem? That's certainly viable and could be solved with the exact same architecture patterns with more dollars, added to the equation, and maybe you solve a couple extra things like storage that we mentioned. Or you could say, we don't want to invest in cost per copy, and we're going to do as much exfiltration of data out, or we're going to compress, we're going to aggregate for a while, compress the best we can, ship when we can. In our world, like we're online a lot, so edge helps us if we are offline, but we're able to connect to the internet a lot most of the time, actually. So we'll send business data out, like I would consider data from fryers, grills, holding cabinets, all the things that kind of make our kitchens go. I would consider that to be business data, and so we would send that stuff out when we can. If we're offline and we can't, we'll basically store and forward. But if we start to use our resources at the edge, like we're running out of space or something like that, we'll start chopping things off and allow those to disappear. So there's a number of strategies. I think it's just a question of no perfect solution. Where are you going to take the trade-off in that equation?
How are you egressing your data now?
Yeah, that's.
That's an important piece. How much does it actually cost you? Are you egressing through the cloud? Because that's probably not wise.
Oh, no, we pay, I mean, we are a platform, so we give the solution. If you keep it at the edge, it costs zero. The problem that we see is, or the problem that we solve If you try to keep a lot of data at the edge, it could be really hard. Data is distributed. You don't have a lot of resources. So that's exactly what we solve.
Right.
And that's why
What's your edge, though?
whatever you want. It could be a small switch.
Roger, I'm saying, but if it's the fridge, then you have a certain like profile. I'm assuming some sort of, embedded kind of computing system, right? Whereas like this is fully a fog edge, 120 terabytes of NVMe storage, Ceph is 16 OSDs. Like, how much data do you need?
Right. So it's a cost question.
It is
right?
definitely a cost question.
Yeah, but for sure. So I could give you an example if you want to go there. So one of our places that deployed our platform is a city, the city called Sabetha in Kansas. And they have a lot of infrastructure, water, wastewater, electricity. They used to take the data to the cloud. And it was a very expensive setup, very expensive. So they replaced it with Edge Lake. And then the data remains at the edge. And then the cost is zero. And when applications look at the data, they see exactly what they would see if they were to move the data to the cloud. That's what we do. That's what we try to enable. So that was, that was the question. What do you do? And I understand that you move the core of your data to the cloud.
Yeah, we prioritize basically, and I probably shouldn't have said cost equation. I should have said value equation, where cost is a huge component of that. But what do you get in return? Probably a mistake in my wording there, but I think that's the question: is what do you get value from? And if you do, like in our case, we have 3,000 plus restaurants. If we do want to create models on top of data that need to be bigger than a single location, and we want to look across all 3,000, we are going to have to move that data somewhere most likely, and so there's a cost to that, and hopefully a value that you get in return. But if you can do what you described and you can keep things local, we have some other Edge Monsters friends who I won't name, but they do the exact same thing. They keep huge amounts of data that they have to keep for regulatory and compliance purposes and things like that at the edge at all times, and they actually run their analytics straight from there. So they're investing a lot in storage and simplicity of storage and support of storage, but a really strong storage architecture at the edge so that they can feel confident that they can retain all that data, run the things that they need to at the edge, and operate that way. So yeah. Do you want a shirt?
Sure.
Size?
Extra large.
All right, coming at you.
So just to point out a little bit about egressing data, if you're spending a lot of money on data egress on the cloud, do you really need the data to go to the cloud, or are you trying to bring it back to your traditional data center with your business operations, at your headquarters? If so, you don't necessarily need to actually move the data across the cloud. All you need to do is have a routing table that lives in the cloud, and you have a coordination network, and then your data center then just BGPs to your cloud edge, and then you can egress that way across your ISP, so you're not paying for this ingress-egress cost. You can do a global delivery, content delivery, like coordination network, $600 a month. That's an HA.
Well, but you end up putting your data on Snowflake or some cloud.
No. If you want to, sure. But if you want to do your analytics and your data science practice, and you want it to be on-prem, then you don't actually have to go through them. All you have to do is some region pairing, and you hold the routing table of, hey, I'm here, hey, I'm here, hey, I'm here, and then I just UDP hole punch right over to Maxi, because Maxi wants my data. Hey, I'm here, and the cloud lives up there, and it charged me for like 2 bits.
But then you have to build the platform.
Yes.
Yep.
For sure. Yeah, no, there's no free lunch, for sure.
Yep. Cool. Another question?
Yeah, I got one
We'll
here.
get you next.
Sorry.
No, you go ahead. We'll get to him next. He's raised his hand every time so far. I'm starting to feel guilty.
I was curious because we actually drew some inspiration from your 3 NUC approach like 5 or 6 years ago while working on the Edge platform.
I hope it turned out well.
So I was curious, just particular lessons, insights you've learned from that strategy, because clearly it's still working for you. And then the second was, you mentioned taking down credit card processing due to telemetry data. Do you have any other interesting war stories to share with us?
I'll have to think about the second one. Let me talk about the first one. Maybe you can tell some war stories too, I'm sure.
Yeah, actual war stories.
No, not that
Horrific.
kind, the edge kind.
No, that's what I'm talking about. I'm talking about IT problems.
I'll take the first one. So yeah, the 3 nooks. So I talked about it a little bit today, but maybe like a little bit of inspiration from Google in our thinking when we first started, which was like, can we just use commodity stuff and have something that layers across it that lets us accomplish our goal? Can we do our first iteration at a very low cost? And then can we meet the demands of our constraints, a lot of which were space, initial budget when we were proving this out, because nobody really was doing stuff like this in restaurant chains. And so there were a lot of things that went into starting simple, starting small. And so that actually has served us extraordinarily well. I think maybe we got lucky a little bit, but we did put a lot of thought into trying to right-size our initial investment in terms of what we anticipated coming, how long we thought hardware lifecycle would be, all those kinds of things. So I think we kind of nailed that. We never really had resource problems in our first iteration where we maxed out everything that was available, so that was good. We didn't have to add N+1 node, which we had intended to be able to do, but we had constraints at a restaurant network level, which our initial team did not own. So it's like, you have 3 ports. We're like, where are we going to put the 4th node? And it's like, you have 3 ports. So realities that exist in these kinds of environments, and in physical space, like I mentioned as well. So that's worked out well. We're doing very similar in our hardware refresh, which surprisingly, I guess we hit full chain-wide maybe 5 or 6 years ago. I don't remember the date now, but the initial iteration of hardware lived that whole time period, and we're currently in a hardware refresh right now. So that's been fine. We didn't do anything too crazy there. I think we'll add a little bit more capacity, and then obviously the next question for us, like everybody else, is everybody wants to AI all the things. If you're going to AI the things at the edge, what does the infrastructure for that look like? Keeping in mind the multiplication of number of copies, times expensive, potentially expensive GPU or whatever, even if it's just for inference purposes, large language model in the store or whatever. So TBD on that. I have theories, but I don't have anything in practice yet, so I won't spout random stuff at you. You have any stories top of mind that you want to share real quick?
Sure. Horror
stories?
stories, switches that don't work, and we find out, we get them sight on scene at like 10 p.m., and the deployment has to go onto a major weapons systems floor that's like, I don't know, bombing Syria. And the switch doesn't work and has the wrong operating system on it. And so these things, so I just point this out, like, I'm the guy with all the wires and the stuff because like I have so many scars from like horrible things, right? So like these modules, so port flapping, like you gotta like really recognize like the tier 1 problem is a big deal, but then also like the tier 2 problem is a huge deal too. Like modules, don't buy them cheap, because you'll be at the TRU hotel lobby till 5 a.m. and you have to deploy at 6, and a bunch of generals are counting on you, kind of thing. And why doesn't it work? Why does it work? Why do the DACs come online and then fall off a line? Oh, and by the way, the problem with that is your storage array never comes up. So you have to really think about like, how are you doing storage appropriately? Where is that? What are you going to actually like keep? What are you going to throw away? How do you egress the stuff you want to keep? And yes, that includes config. If you are connected, why wouldn't you? A disaster recovery of config is much better. Being able to do it quickly because you have an actual copy instead of having to rerun the bootstrap. Seriously, you can just like apply, config, off it goes. Horror stories. Yeah, that's close.
This isn't
sleeping in a tent, sleeping in a van.
Sleeping in a tent's awesome.
Yeah,
so is a van.
For a week while like in the hot Georgia sun. As you were saying, sir.
I thought of a funny one. I don't like it as much because it's not something that we did wrong. I'd rather ding ourselves, but we did have a vendor that makes one of the kitchen equipment components that denial of serviced our I can't remember if it was the prod or dev environment now, actually. It mattered a lot at the time, but they were basically denial of servicing us by hitting us with like, I think it was fryers. I think each fryer was sending like hundreds or more requests per second to like our auth service to try and onboard itself into the restaurant. And I'm not sure if that problem has ever been dealt with. I think we just like black holed it from a network rule perspective in AWS and never thought about it again. So I don't know what's going on with those, but they were still working, but also like denial of servicing one of our services. So that was fun. And
I got a
exciting.
counterpoint for you.
right,
So
please.
2 weeks ago, I dug into a legacy environment that was sort of non-performant for me, and dug into the logs, and apparently nobody else had in a while. So for the last 2.5 years, it had been trying to call out to GitHub and do a pull every 3 seconds. So be careful about what your services actually do as configured. If you're actually on the edge, and I know you say you have
I think you just described GitOps, right?
Yeah, well, when there's no internet on the other side and we have no router, kind of pointless, right? But yet, sure, there it is. It's like, who's got? It's trying to do some DNS call to nowhere. And then, of course, we have like 4 of those services I found. So now we have a 4x every 3 seconds. And they're not all within. So basically, we're DDoSing ourselves for the last like 2.5 years.
Yeah. Do you have any advice on how to avoid having that happen if anybody here is doing Edge?
Yeah. Hire a network engineer. Yeah,
Wonderful.
you know, maybe not the Cisco CCIE, like, $400 a year dude, but at least somebody who is conversant in Wireshark and understands how it should behave and does some packet stuff. And you don't have to go ad nauseum. I don't think it makes sense for you to like go nuts on eBPF unless you are as securely focused as we are. But then that's kind of overkill anyway. I think some really common sense approaches to understanding how to do old school development and environment and understand the full stack people. Yeah. And I'm saying I'm a full stack person because I'm old, but a lot of people started their careers on Heroku, so they don't really know like what that really is. So make sure you find some people that know how to do this piece. And my big advice is really like try to create hardware parity and replicate the environment that you're deploying into as intensely as possible. And no, I don't mean build some sort of digital twin. Actually go get the hardware, plug it in, put it into a sandbox environment. A faker EC2 digital twin is not going to get you to the problems with like some ASIC type action going on inside of a cluster.
Yep. All right, we're finally getting to you.
All right.
I think you're good to turn on.
Any security issues that have surprised you in edge computing? Something you didn't expect?
Yes.
Lots.
Yeah.
I'm thinking.
Yeah.
Sure.
So I think part of the problem is that somebody actually has to do the security review piece as opposed to just turning on a logging seam or some sort of seam and a log aggregator and go like, look, we've got Logstash and Splunk, so we're good. Somebody actually has to read it. Just like, I think part of the problem with like software bill of materials and various things like this and scanning is that, yeah, that's really great. We already don't read the logs we have. So who the hell is going to read this manifest? And I go to so I have what's known as an AO, an authorizing official. And then we have SCARs and SCAs. We love our acronyms in the military. These are people that like look at your configuration and say, ooh, that's good, that's not good. And then the person who your AO is that's sort of a figurehead. There's SCARs and SCAs, like they can't read the authority, the risk management framework stuff that we're already providing them. They're asking us questions like, is Windows RDP turned off? And you're like, dude, it's a Linux environment. Yeah, but is Windows RDP turned off? So if we go like hardcore on SBOM, then who's going to read it? How's it going to be? Are we going to actually have to use an LLM that was written by China from DeepSeek to tell us whether or not we have any vulnerabilities? And then it says no, right? Like do the differentiated heavy lifting. And I think that slide really lands in like you just have to intimately know. Like,
back to it again.
If you sleep with it and you spend 5 years thinking about it and turning it over and over and over, you can really understand how to get it. And there is no like, the other piece is like, Remote lights out is super useful. Even if it's like a dude, right? One, like, hey, push the button again. Push the button again. And if you've built to a point where like you can actually power this thing so that you have like an A plan, a B plan, a C plan, a D plan on the comms piece, then you can get back to, I can get a team digitally in that environment that then can deploy and troubleshoot and fix the system. The other piece that, horrible things that I did before, not having an A/B boot slice, so when it doesn't boot and I'm far away, game over, plane ticket to Hawaii. Like, I was deploying this stuff to Hawaii. That sounds really great for you guys, but I lived there for a long time, and I didn't really want to go back at that point because I had a baby. So, you know, that's the piece, is just like you just got to understand one piece of hardware really, really, really well, and then try to be very knowledgeable about as much of the stack as possible. Don't use commercial product. It'll lie to you. Single pane of glass, you know, that kind of problem. And then you find out it's really, you're just their beta tester. Yep.
Given that this is the Open Source Summit, is that switch that you're holding running OpenWRT or open source software?
Yeah, so this is actually running Viata under the hood, and we have cracked into the Unify OS and reprogrammed that for Viata, pure Viata. So yeah, we do chase open source things. And I will say that is actually an Achilles heel. Switching is a just terrible thing, right? Like, there is no true open switch. Sure, you can say Sonic. Sure, you can say these other things. Maybe you can like get that on an enterprise level for you know, like an exascale data center or a hyperscaler, but you got to buy their big chassis. You got to do these things. It's not a half width. This isn't even a half width. I do roll with a Mellanox as a half width, also not open. But you know, like deploying an edge core with Sonic is great, but how do I get like a small tactical switch? And I think I would love to see switching just like let go, where I could just get a box with a bunch of ports and it was actually performant. I've seen boxes with a bunch of ports, but then they suck at the performance piece and the back end doesn't provide you with high speed. Really, a Linux box with a bunch of ports would be perfect. I have not been able to get that done.
Okay, and same type of question for Chick-fil-A. Are you using open source in your edge components?
In the edge what?
In your edge components at the store?
Oh yeah, absolutely. Not in the networking stack specifically, but pretty much everything is. Nothing in our environment is commercial, like from a software perspective. It's either custom written out of necessity or it's open source. So I'm trying to think of quick examples. I mean, Kubernetes K3s specifically is an obvious first choice, but we use a whole bunch. I mentioned Vector during the talk earlier today. We'll probably move to Argo as opposed to our custom thing that we rolled, on and on and on. I think there's probably across our cloud control plane side and then the edge deployment side of it, there's 20 plus major open source projects, and then programming languages which are effectively open, and operating systems and all kinds of stuff. So we use it top to bottom, just not on the hardware side. So.
Thank you.
Yeah, so I'll talk a little bit about the software stack if you're interested. I thought it was directly about switching. Yeah, so from the bottom of the top, I do not use any paid product, period. We deploy Rocky in our controller, then our controller is essentially running Podman. Everything then goes Ansible. From that, we deploy KVM. So we are deploying Rocky across these. It's all bootstrapped. We use a kickstart. That kickstart brings in a minimal kind of action. There are some certificates that get deployed to that. Our software-defined content delivery network is part of that. That then once this thing, like first contact from micro SD card, which I showed off on my talk, to actually building this as a full controller, there's an ephemeral token. It's a 48-character joining key that then gets you onto that content delivery network. Then we are running, we're running Nexus, we're running Harbor, and various other things on the other end of our cloud. of that content delivery network. And then once we deliver that payload, we get out of the business of cloud, and it's all coordination network from there on. That's the $600 a month kind of action on, let's just call it 6 availability zones around the world. And then from that, we deploy KVM. We're using Proxmox. Proxmox, then we build up Rancher RKE2. We also do vanilla Kates. We do micro Kates if you so feel inclined. This design pattern actually scales down, so we do a bunch of system on a modules. So if you look, we stick with just like the 3 NUCs, we're 4 blades, right? So we can lose 1 full blade and still keep HA. Very same thing. We do system on a chip, and we'll do 4. Right, and then we'll have a controller to that that's a separate piece of hardware. That way we can lights out this thing software defined differently than the rest of the, we try to keep a distance between the controller and the actual stack we're deploying. And then this scales down, like I have a picture, the robot you saw in the talk, that actually is holding a cluster exactly like this inside of a hermetically sealed little metal box that's passively cooled, and that has 4 nodes in it. Now the rest I can't really talk about, but yeah, so the idea is that we go from the bottom to the top on open source software, and mostly in and around being able to apply like an Ansible operator type setup. And then we just apply data center with this hardware configuration, and off it goes. And then after that, we deploy a security manifest known as Platform 1 Big Bang, which is the platform of record for the Air Force. It's a helm of helms. And then that deploys like 40-some different pods. They love bloat. The DoD does. Yeah. I would like for them to make a minimal, like a LITE version, and I've pushed them to do so. Any other questions? Yeah.
Have you found any kind of a use case for like an iDRAC or ILO type?
Oh my gosh, yes. So actually, we are using ILO on this. ILO is great because basically, we compose the hardware and scan the hardware too. This is actually giving out some of the secret sauce. We use Redfish APIs. We pull all the MAC addresses. We pull the hardware. So we pull like, so I want to know dev, SDA, this NVMe. So all the hardware I don't know a thing about. This doesn't know a thing about it until it hits the Redfish API, scans all the hardware, and it tells it what it is. Additionally, we usually deploy a console cable to something like this. And then I will go after what vendor is it? What console speed can I get it at? And then I start jamming commands in it and see if I can bring the switch up. Yeah.
Okay, so.
Oh, but IPMI, not so great. JNLP, that like Java kickstart stuff, my God, I don't enjoy it. Yeah.
Okay, so we've done war horror stories both sides, but can I swap to success stories? Can I ask first, Chick-fil-A? Can you talk about all the different sort of devices you're collecting metrics from, and which one is like most fun to justify purchases to the finance department about?
Yeah, I mean, like ultimately, it's a simple business, right? Like Michael has way more complexity than we do. We're trying to serve people chicken sandwiches, and so I mean, almost all the things that are connected are effectively equal. It's like kitchen equipment. And it's like sending out data, or in some cases, it's starting to be able to take commands to do things. So I think that will be. We aren't there. We haven't automated our kitchens. I think we will have some automation in the kitchens to augment people in the very near future. It actually is something we anticipated when we started this whole journey. It's just been slower developing in the physical world, as you might expect. Complicated processes, quality's got to stay high, et cetera. So I think when that is true, that will be the really exciting thing, which is like you effectively have a brain of your operation that can orchestrate and manage through applications deployed in a way that developers are familiar with, and containers orchestrate things that exist in the restaurant and make stuff happen in the real world. So I think that's going to be the real winner over the next couple of years. But to date, it's really more about data collection, bringing multiple discrete things in the store together to create better opportunities for the team members to make decisions about things. Like the example I always use is you need to know what's cooked. That's a function of really what's your current demand, what's your incoming demand, how long does it take to do things, et cetera, right? You can imagine. We do some stuff to help with that, to make those decisions about what to work on easier for team members, so less cognitive load and hopefully higher quality, shorter waits, et cetera. So stuff like that.
So you're able to use kitchen data or kitchen equipment data to help with demand forecasting?
Kitchen equipment data wouldn't necessarily be the demand forecast side, so that would be more like camera vision, which is another effectively type of IoT device I haven't really talked about at all. But that's another thing that's in our environment as well. So there's a number of different functions coming together in order to make something like what I described happen. And another one might also be what comes down from the cloud. So forecast I think we do it at 15-minute level typically. So 15-minute demand forecast that then can get adjusted at the edge. So a lot of that is in-store adjustment to something you could compute in the cloud to make the best possible recommendation to a team member in the store at any given moment.
Cool. Well, thanks for sharing.
Yeah. What about you, Michael?
Well, I did want to comment that his agentic agent, probably when you get a health check, the very last element says, "My pleasure." So yeah, what about me?
I should do that.
Success stories. So we built this thing. This is not the exact one that we built, but we were able to build this in 6 weeks and 700 hours of work on 4 senior engineers and 10 people that had just gone to like some cyber intensive Udemy type course. We had them do DNF, and we were actually the very first node to deploy for a $900 million program in the Air Force. And so we beat out the big boys. So we beat out Red Hat. They couldn't get OpenShift running in time. We beat out some other like Home-rolled rancher type stuff. There is a Lockheed Martin component to that. Is this camera on? But yeah, so we showed that like we can do it on all open source software, and we can do it directly with like a small team and do it in an agile way. And the Air Force really likes to buy things in 20-year increments. The first 10 years are gathering all the perfect requirements for the obsolete product that we're about to buy. And then the next 10 years are trying to actually figure out who gets the contract. Well, the next 2 years is figuring out who gets the contract, and then the next 8 years is fighting on the recompete to fix what was a disastrous idea in the first place. So I think being able to say that we can do software-defined infrastructure as code in the Air Force is something that is like an absolute huge win. And also being able to push the idea that the DoD and the government at large should be one of the largest open source contributors, just period dot. The fact that we can use open source software and do our classified processing and not think that we're so unique beyond everybody else. It's one of the problems that the government has is that they say, well, I don't think you understand our problem. Like we have classified stuff and like we're gonna go to war and stuff. It's like, dude, banks don't lose money. They use open source projects. So why can't we? And if not us, then who, right? So we should be plugging the holes in the security of open source projects in a massive way and providing our vendors a design pattern of like, I did this one, so please don't charge me for it. Here's the actual manifest on how here's the LOM, here's the software bill of materials, here's the manifest on how to deploy it. Go do the next level of differentiated value. Don't recharge me for the same old thing. That's a huge win. Yeah. Go ahead.
Quick point of clarification. Are you finding a lot of value in SBOMs and vulnerabilities and managing that in your stack, or how's the noise to value ratio for you?
If someone would read them, so I'm a big like Waze fan, so I'm deploying like a Waze XDR, playing with that a lot. I have a large lab, so I get to play with the lab thing, and I also own a bunch of networks. So I get to play with some pretty cool stuff. I do think that there's a problem with like, it's like bloggeria of logging and scanning. If you don't really know what you're looking for, then what's the point of more? We need more signal than we need noise. I think that there is like a real problem with attestation. I think there's a big problem with us just hand waving over the BIOS and going like, that's fine, it says American Megatrends, what could be wrong? Or what else is in here? I think that there's a really, really interesting project known as OpenBMC that the Jan 11 and 12 servers are coming like compliant to. So now we can really do our own BMC and figure out like what do we want running in this environment, and why is this coming through in Chinese? Yeah.
So I come from the embedded Linux space,
Yeah.
where it's all pre-built images and all that. And I'm kind of curious. You mentioned your tech stack's generally Rocky with like Ansible built on top of it.
Well, it was CentOS, but
Sure. So
IBM.
I'm kind of curious, like at a high level, why for like edge computing you guys go with like doing Ansible and like a Rocky image versus like building your own distribution, like
We sort of have our own distribution. So first, I want to consume it as I can get it, right? So like I want to basically take the principle of GOTS, like open source first and like unmolested open source first, closest to the upstream repo. We are kind of rolling our own, but we don't want to roll our own kernel completely. Like I think that's a bad idea. I want to stay in the protection of tens of thousands of contributors. I don't want to be like the guy that went, oops, bit flipping was a bad idea on this key thing, right? I think that's what closed source software does, is they take all the risk for you behind the covers, and you pay them to take the risk, and then when the exploit happens, they go, ooh, my bad, and then they kind of go on a campaign to talk about how bad the bad man was, and please don't SolarWinds 1, 2, 3. Yeah, you get my point? So I think that we probably shouldn't roll our own because we don't have enough engineers to do that, but we should definitely be able to do the integration in Glue.
I guess like maybe a more targeted question is like, as far as like if you're doing containerization and all that, like build the most minimal image that has the least amount of things. Like, going to the security side of it.
For sure.
And then
projects I'm playing with. I'm starting to look at EVOS. I'm starting to look. I've been looking pretty heavily on Talos, CareOS, CoreOS. Like there's not a hardware. There's not a piece of edge hardware I haven't looked at, and there's not an operating system offering that I haven't looked at, except for some like weird esoteric stuff somebody's building in their basement. But really, if it's a Linux Foundation project, I'm chasing it. Yeah, minimal operating system is really great. I would actually like to get out of a hypervisor altogether. We have lots of, I have a configuration that's all bare metal, like Kubernetes on metal. But the DoD loves their VMs. Like, man, that VMware cult is like locked. But I am very excited to see like what has been really happening with Canonical, and they're pushing back and keeping OpenStack and kind of doing some stuff with OpenStack. I don't think that there's really like one exact pattern. I think that there's an architecture and a deployment pattern, but there's not like one exact manifest to get you there. There are many roads. I've played with Tinkerbell. I've played with Foreman. I mean, there's just like tons and tons of different orchestrations that I played with. I used to be in Terraform, but then Terraform kind of went and jumped the shark, and then OpenTofu. So we got scared, and Ansible Galaxy has a lot of offerings. So like, when you have like 3,000-4,000 things to choose from that comes out of the box from Galaxy, like it's got the wide adoption. Does that answer your question?
Yeah, thank you.
Yeah, I try to play as much as possible in the placemat.
Do you want a shirt?
Yeah, large.
Gotcha.
More questions?
Anyone else while we're waiting on a shirt? Yeah.
Yeah, so you guys kind of touched on it a little bit, but jumping off the success stuff, where do you guys see edge computing being in about 5 years? Any like emerging technologies you're really excited about?
Oh,
or like
yeah.
What would make the Chick-fil-A the future? Yeah.
So for me, ESP32 and like Corel in like a really low thing. I hate barrel connectors, so I would like some more USB-C on tiny little things. I am very interested in hybrid drives also getting DPU. So like, being able to like embed computing directly on the network interface and then have that kind of thing behave directly with storage. Maybe we don't need a full compute platform. Maybe the sensor, think of it as sensor plus, right?
Yeah, I know I said it before, but I think the possibility of doing like simple agents at the edge is interesting. It's a data-rich environment, right? Like the whole thing you're doing is bringing compute to where the data is. So I think there's potential there to do some really interesting things, both for business purposes, but also like operating the platform purposes, like reading all the stuff that nobody ever reads, and doing all that stuff like in the environment and taking action on it if needed in the environment. So I think stuff like that. I think what Michael talked about from like an edge controller pattern a number of times, I think is really a huge thing. That's not something we did. We effectively use the cloud as our edge controller in our world. I think a physical one is actually really a really cool pattern that's going to scale really nicely in a lot of environments too, especially when you've got like a heterogeneous set of compute and use cases and configs and all that stuff. So I think it's a mix of those couple things. Anything else you want to add?
Yeah, I mean, eventually you're going to have some sort of McFlurry machine that's only at certain locations. It's always broken. Why is it always broken?
Ours is not broken.
I think that like he's spot on with like the next thing is like these robotic frameworks. Really being able to do advanced configurations on infrastructure. I kind of jumped into this really early with Robot Framework, and then there's all these other projects that have kind of jumped in. So I invested a bunch of time in Robot Framework, and now there's like this 808 and various other things that are creating standards that may or may not fit in with the kludge that I did in my lab. But I definitely think that there's these like intelligent ways to do health checks and then have them figure out how to fix it. And what does drift look like? One of the projects that I was involved with was using the Corel chip to look at system drift, right? So if you have a bad actor that has worked their way into your system, that system changes live while it's going, and we had a Corel chip identify that bad actor, get into the system on a chip while flying. And so this was directly for like, you could think of it as flying things. Autonomous flying things. So you can see why we care about that kind of thing. So you can like get these small chips that do inference and say, oh my God, bad things have happened. Go to the B slice right now, right? And I think that decision to go to the B slice is like an interesting, really good rescue boot. You can think about rescue boot agent as like an immediate thing that you can do with these sort of like agent frameworks. And you can, Ansible is so prime for this. Like all the infrastructure is already laid down, all that software-defined infrastructure for being able to deploy like an agent directly on top of it, have that inference Corel chip decide B-slice time because I think bad things are happening, or it's just non-responsive. I mean, the error 500 code, go Bork, is still very much a thing in computing. So if it go error 500 go Bork, then B-slice. Now, there are things where like, no, it says it's live, it passes health checks, but it's still not doing this, and this, and this. Those are very simple checks, but pretty soon you can start getting to performance metrics and behaviors associated with performance metrics. Is the network behaving appropriately? Can we fix the switch? Those kinds of things.
I think we got time for one more, 2 minutes left. Anybody else have a final question?
I got one.
Yeah.
So other than reading the Edge Monsters blog posts, how do you get started? Should you be focused on the app? Should you be focused on the hardware, the infra? Like, where to begin? I know Michael's answer. How about you, Brian?
I mean, I think that's a pretty good answer. I like that. Let me think if I have anything else. Do you want to expound on yours at all?
Yeah, get started super low cost. Stay under the radar. Don't let your organization chop your knees off, because honestly, like, there are a lot of people that, it's not just my organization. When you start doing these kinds of things, the admins get worried, right? Maybe it's time to like do something interesting with that. Not everybody is on Team Michael, clearly. But no, you can start off really cheap. You just have to have a representative environment like where you think you want to deploy this to. So, you don't have to spend, well, this is very expensive. You don't have to spend very expensive, but you still have the pattern. You have 4 nodes, you have a switch, you have various means of communicating. You've got like this little controller thing. Well, I'm not gonna dig it out, but like you can just straight up go like Raspberry Pi 5. Almost all the things you need to really explore can be fit on that. Is it the exact delivery platform that you're gonna do? No, you're gonna probably pivot to something where it's like a little bit more like you can like bang the crap out of it, and like wherever it's going to deliver to, right? Does it need to be waterproof or IP rated kind of thing?
I think that's good. I would add, we talked about a ton of technical stuff, and like adding things to the solution is really fun, and learning all the new stuff is really great. I think if you're getting started, my main advice would be like radical simplicity. Like if you're not 100% sure that you need something in the solution, don't put it in the solution until it's proven that you do. And that is probably like the best key to success.
sure.
Like be willing to make architecture trade-offs, because you will, the scale will demand that you do. So if you think about them intelligently early, I think it serves you really well as you grow and deploy and scale a large footprint. So.
More is more. When you start deploying your yes, I need an SMTP server to then send emails, then you're probably doing more than you need to. There's just like cleave away the excess cruft and think about like the pattern the architectural pattern you need to deploy into, and just like Colin Chapman from Lotus, right? Like add lightness. Make it fast, add lightness. Just keep building a really minimal race car. And that's really what Edge is about. Like people will tell me this is not an Edge, and it's like, okay, well, the requirements to me was we need to have 250 people be able to log in and do a bunch of other things. And yeah, they want a PowerPoint, and yeah, they want to do this, but the legacy requires this. Maybe I'd be happy just in these two devices if we could get the less part done. But if you have a way of just starting with less, then you can handle more.
Awesome.
They'll force you to do more, for sure.
Love it. Well, we'll declare victory. We have more shirts, and we want to give them away. So if you didn't ask a question but you want one, come forth and please take them.
For
Take
sure.
them home to your family or whatever.